Okay, so in this video we're going to have a look at 5 of the hardest probability questions. These tend to involve algebra, but may also involve some probability trees and just different methods that we're going to have a look at. So we're going to have a look at 5 different questions in no particular order of difficulty. The one that you can see on the screen is the one that we're going to kick things off with. So with that being said, let's get started. Okay, so looking at our first question. Now, as with all of these, I do encourage you to have a go at them, so make some notes, write the question down, see how far you can get, and then go through the solution with me. So make sure you've grabbed a piece of paper, grab a pen, and let's get started. So it says here there are only R red counters and G green counters in a bag. Essentially, we don't know how many are in the bag. A counter is taken at random, and the probability that it is green is 3/7. So we'll highlight that. The counter is put back in the bag, and then 2 more red counters and 3 more green counters are put in the bag. Another counter is taken, and the probability that it is green is 6/13. And it wants us to find out, okay, well, how many red counters and how many green counters were in the bag originally? Now, I think the first thing that people tend to try and do on this question is because of this language here where it says there are R red counters and G green counters, people try and make some sort of algebra using the letter R and the letter G. Now this can be done, although we can actually avoid it and make this question an awful lot easier by just using one letter and thinking about how we can apply that. Now, as with a lot of these questions, when we don't know the amounts, we can write things in ratios or we can create expressions. Now, I'm going to take one approach to this, what I think is the easiest approach, although if you can obviously apply a different type of method and a different approach, that's absolutely fine, as long as obviously your answer matches at the end. But the method that I'm going to approach, so it says here that the probability of getting a green is 3/7. Now, if we write this as a ratio, we've got green to red, and that's 3/7, so that is 3 to the remaining number up to 7, which is 4. So we know it's in the ratio 3/4. Now, instead of writing 3/4, we can write that in terms of algebra. We can say 3x and 4x. Obviously, it's not necessarily going to be 3 green counters and 4 red counters, but we have some multiple of 3 and 4 in that ratio. So instead of writing 3/4, let's write 3x to 4x. There we go, and that's our ratio sorted for that first statement. It then says the counters are put back in the bag, 2 more red and 3 more green counters are added. So if we use this piece of information here, how does that affect our expressions here? Well, let's start with the green, as I've got green first in my ratio. So my green one would now be 3x, the original amount that we don't know, but adding in an extra plus 3, okay, exactly 3 more counters. So that would be my new expression for green, and my expression for red would be the 4x that we've got at the start, plus an additional 2 counters. So there are my new expressions once these new counters have been added in. And we know that the green, or the probability of picking a green, is 6/13. So what fraction, what expression can we make for the total here for our denominator for our probability? Well, if we add both of these together, that's going to give us our total amount of counters in terms of x. We have 3x and 4x, which adds up to 7x. And then we've got 3 add 2, which adds up to 5. So we know there's a total of 7x plus 5, whatever that value of x is. So if we write this as an equation, then looking at that green probability, we have the 3x plus 3 as our probability for green out of 7x plus 5. So let's write that down. We have 3x plus 3 over 7x plus 5, and we have been told that that probability is equal to 6/13. And there we go, now we've got an equation. Not the nastiest of equations to solve either, we just need to do a bit of cross multiplication to get rid of our fractions here. So we're going to multiply this denominator up to the 6, and this denominator 13 up to our 3x plus 3. That's going to create a nice straight line equation. We'll get 13 brackets 3x plus 3, and that is equal to 6 brackets 7x plus 5. And then we just need to expand that out and solve it. So if we expand that out, we get 39x plus 39, times in them both by 13, and that is equal to 42x plus 30. There we go. So again, removing our smallest x from both sides here, just to solve this like a normal equation, we will remove 39x from both sides. So we've got 39 equals 3x plus 30. Now we can subtract 30 from both sides. So we get 9 equals 3x. And dividing both sides by 3, we'll get x is equal to 3. Now, there we go. We've solved it. We've found out what x is. But let's not forget we need to actually answer the question here. Now, the question says, find the number of red counters and the number of green counters that were in the bag originally. Well, the information about how many counters were in there originally is in our ratio just here. We have 3x and 4x. Okay, that was our original expression that we made for the counters. So in terms of the original, the counters in originally, for green, we've got 3 lots of x. We know that x is 3, so let's write this over here. We've got green, which is going to equal 3 lots of 3, which is 9 counters. And for red, we've got 4x, so 4 lots of 3 is 12. And there we go, there's our final answer. So green is 9 and red is 12. Okay, not forgetting, all we've done is we've subbed into here our value, x equals 3. And there we go, there's how to solve that. Okay, so there's our first question. Obviously, if you got your answer 9 or 12 a different method, that's absolutely fine. There are a couple of different ways of doing this, but I think that one there is the most logical, or certainly the quickest method in order to solve this one. So there we go, let's have a look at our next question. Okay, so for our second question, we're going to have a look at using a bit of a probability tree. So it says here there are 10 pens in a box, there are X red pens in the box, and all other pens are blue. Jack takes at random 2 pens from the box. Find an expression in terms of X for the probability that Jack takes 1 pen of each colour, and give your answer in its simplest form. Now again, with a question like this, we can write our different colours here in a ratio. We can say that in terms of our ratio, we've got red and we've got blue. And for red there, we know it's X. For blue, we don't know at the moment, but we know that the total is 10 pens. So for blue, in order to get the amount of blue, we would take the total, which is 10, and we take away however many that are red. And in this case, red is X. So we would do 10 minus X, and that would be our total there for blue. Now that's going to allow us to create our fractions here for our different probabilities. Now different to the last one, because we are looking at 2 separate probabilities here. And when we're doing that, when we're looking at these sort of journeys, it's easy for us to draw a probability tree. Now that being said, you don't have to draw a probability tree for these, but it does sort of make it a little bit more visual and a little bit easier to understand. So let's have a look. We've got red and we've got blue. And on that first pick there, when we take that first counter out, and just something to mention here, although it does say in the words, Jack takes at random 2 pens from the box, the only way that we can work through this problem is to imagine that we first take 1 pen out, assess the probability of that, and then once that pen is removed, we take out a second one. So we're never going to remove 2 at once. We're going to work on the premise that we take 1 pen and then take the second one. So having a look at this then, we've got red, which is X, the probability of red, out of 10. For blue, our expression there for blue is 10 minus X over 10. Again, just taking these probabilities from up here, X out of 10 and 10 minus X out of 10. Now for the second one of our counters now is going to be removed. So if we now take out a red, it's going to be different. And if we take out a blue again, it's going to change this slightly. So let's label this up red and blue. And this one here will be red and blue. Now, as we are looking at the probability of having different colours, so that's what it says, we want the probability of, and let's just highlight it, 1 of each colour, we don't actually need to look at red, red or blue, blue. But for the purpose of our learning here, we'll have a look at filling in all of these probabilities. So for that first one, if we take a red out, it's going to be X now minus 1, because we're taking 1 of those reds out. And it's no longer going to be out of 10 counters, it's going to be out of 9, pens. So X minus 1 over 9. Okay, so onto our probability for blue. If we take out a red to start with, our numerator there is not going to change. So that is going to stay as 10 minus X, but now that is going to be out of 9 as one of those counters is going to be removed. So there's our two probabilities there for red and blue on our second part of the journey. Let's have a look if we've taken out a blue counter. So if we take out a blue counter, the numerator for red is not going to change, so it's going to be x, and that's going to be out of 9. And if we take out one of those counters for blue, then the numerator is going to reduce by 1, so that would be 9 minus x, and that again would be over 9. Now again, we don't need the full journeys here, we just need to have a look at the two different counters. So if we go up the red route and down the blue route, that's going to be one of our probabilities. So we need to multiply those two fractions together. And likewise, we could go down the blue and then take out a red. So let's take these two probabilities and write those out. So going up the red and then the blue, we have got x over 10, and we need to times that by the 10 minus x over 9. For the other route, for blue and then red, we've got 10 minus x over 10, and we need to times that by x over 9. So these are the two little fractions that we need to work out. So let's get rid of this tree and we're going to figure both of these out. So let's get rid of all of that. There we go. So just looking at these two fractions then. Now the numerator there, we've got x multiplied by the 10 minus x. That's going to be 10x minus x squared on the top, and that is 10 times 9, which is 90 on the bottom. For the second one, we've got 10x again minus x squared, and that is again over 90. Okay, so we end up with the two of the same fractions here. Now let's have a look. We need to add these two together. Just like normal probability trees, we're going to have to combine these together. So let's just write that out as our actual working. So 10x minus x squared over 90. And we're going to add to that the same thing, 10x minus x squared over 90. Now when we add fractions together, our denominator there isn't going to change, so it's still going to be over 90. But we need to combine everything on the top. So we've got two lots of the 10x, so that is 20x, and two lots of the negative x squared, so minus 2x squared, and that is all over 90, and there is our final fraction. It does, however, say here, give your answer in its simplest form, and if we have a look, we can divide the top and the bottom by 2. So if we do that, if we divide everything by 2, we'll have 10x again on the top, minus 1x squared when we divide everything by 2, and then also 45 on the bottom, dividing that 90 by 2. And there we go, there's our final answer, 10x minus x squared all over 45. Cool, so that's our second question. If any of that was a little bit too quick for you, again, I do have lots of videos on probability, and it's particularly these ones involving algebra, so we'll link those in the description as well. So do make sure you check those out if any of these are a little bit too quick for you. But as I said, these are difficult questions, so they do take a little bit of time. So let's have a look at our next question. Okay, so on to our next question. Now this one is a large question, so I would make sure that you write down this question before we get started, because chances are I'm going to have to completely remove everything off the screen to fit this all on one page. So let's have a look. It says that there are only green pens and blue pens in a box. There are 3 more blue pens than green pens, and there are more than 12 pens in the box. Simon is going to take at random 2 pens from the box, and again remembering what I said on the last question, that if we remove 2 pens we're going to remove 1 and then the second, and it says the probability that Simon will take 2 pens of the same colour is 27 over 55. Work out the number of green pens in the box. Now do make sure that you write this question down, because I am going to remove this from the screen in a second. But here we go, let's have a look. There are only green and blue, and there are 3 more blue than green. There are more than 12, which is what we're going to have a look at towards the end, and the probability that someone will take 2 pens of the same colour is 27 over 55, and we're going to work out the number of green pens in the box. So, like we've done on previous ones, let's write a little ratio here for blue to green. Now we've got blue to green, and it says here that there are 3 more blue than green. So we could write this in different ways. We could write that blue is x, and then green would be 3 less, so x minus 3. Or we could write green as being x, and then blue as being x plus 3, as there are 3 more. I think that's probably the easier way to write it here, just to avoid having any more negatives than we need. So there we go, we've got x plus 3 and x, and our total again for that is 2x plus 3. There we go. So what we're going to do is we are going to create another probability tree again, but we are going to be looking at the probability that Simon will take 2 pens of the same colour, and that has actually been given to us as 27 over 55. So if we have a look at creating this, let's see how far we can get on this screen. We can have the probability of blue and the probability of green. So let's have blue going up and green going down. Now blue will be x plus 3 out of the 2x plus 3. So we can write that probability in, x plus 3 over 2x plus 3. And the probability of green there is going to be x over the 2x plus 3. Now again, we are only really concerned here about taking the same colours, so we don't need to fill in every single branch this time, although feel free to do that when you are practicing, because it is good to be able to create these expressions. But if we take out a blue, so our numerator is going to reduce, the plus 3 is going to go down to plus 2, and the denominator, the plus 3 is going to go down to plus 2. So that's going to be x plus 2 over, and then it's going to be 2x plus 2. So there we go, our numerator's gone down because we're looking at the same colour this time. We don't need to do the green one, so let's miss that out and go down the bottom route. Again, we've done this route. Now let's have a look at the other route for same colours, which is going to be green, green. So our green numerator is going to reduce, so it's going to go down from x at the moment, and that's going to go down by 1, so x minus 1, and our denominator is going to go down to the plus 2 in that position as well. So we've got x minus 1 over, and that is going to be 2x plus 2. Okay, so what do we need to do now? We need to multiply both of these fractions together. So in order to do this, let's just create a little bit more space. Okay, so here's all the information that we had written down. Now we just need to work out the probability of each root. So going up the blue route, we have x plus 3 over 2x plus 3, and we're going to multiply that together with the x plus 2 over the 2x plus 2. So this route here, and I'm going to skip a few steps here because I'm going to multiply the numerators and multiply the denominators, but I'm not going to do any working out for that. I'm just going to do the double brackets in my head, although I would suggest that you write that down, but I am going to assume if you're looking at this topic that you're quite comfortable with doing a double bracket expansion. So obviously you do your working out for this one, but on the top there, x plus 3 times x plus 2 on my numerators gives me x squared plus 5x plus 6. And on the denominator there, we've got 2x plus 3 times 2x plus 2, so that's going to be 4x squared. Then we've got plus 4x and 6x, so that makes plus 10x. And then 2 times 3 makes 6, so plus 6. And there's our fraction for that probability there. We've also got green, green, so again, we've not got a double bracket on the top there, we've got x times x minus 1, which is going to give us x squared minus x, and again, our denominator is going to be the same, so 4x squared plus 10x plus 6. Now, we need to add these two probabilities together, okay, because the combination of those two probabilities will give us the probability of getting the same colours. So if we add those two together, and let's write this down at the bottom, we've got the x squared add the x squared, which makes 2x squared. We've got a 5x and adding in a minus x, so that's going to become 4x. Okay, and again, if I just highlight that little bit there, that was the 5x and this minus x that have added together to make this plus 4x. And also at the start there, we had the x squared and the x squared, which has made this 2x squared. Then we've just got the plus 6 at the end and no numbers on the numerator for that bottom one, so that's going to stay as plus 6. And again, our denominators just stay the same, so 4x squared plus 10x plus 6. Now if you remember, and hopefully have this written down, it said in the question that this was equal to 27 over 55. So that is equal to 27 over 55, and now we have our equation to solve. And again, this isn't an easy one. We now have to cross multiply. We've got large numbers in the fractions, but we need to make this a single line, and then we're going to probably have to either look at factorising, or if it doesn't, we could potentially have to look at the quadratic formula, but we'll see what happens as we work our way through this question. But we're at a point here where we've got the majority of the marks on a question like this. At this point, we've got around 3 marks out of what this was, which was a 6-mark question, so around about the halfway point. We now just need to get it into a position where it's a single line and it's equal to 0, as we do with all our quadratics, and then we'll be picking up our next mark before we look at either factorising or whatever process we need to solve it. But if we get rid of all this tree now, we'll just focus on this actual equation that we have here. Okay, so let's just get rid of all of that, and we'll just focus on this last little element here and hope that we get a nice quadratic out of it. Let's just move that up there. There we go. Okay, so we're going to cross multiply. Now that's not going to be too bad. We have got some big numbers involved here though. So let's go through that process. So the 55 is going up to the 2x squared. So we're going to have 55 lots of 2x squared plus 4x plus 6. And that's going to equal 27 lots of the 4x squared plus 10x plus 6. Right, so expanding these out, so times in the left numbers by 55. Again, you can use a calculator for this one, but let's try and do as much as we can. So 55 times 2 is 110x squared. 55 times 4 is going to give us 220x. And then 55 times 6 gives us plus 330. Not too bad. Times in the left side by 27. So 27 times 4 gives us 108. So we've got 108x squared. 27 times 10 is easy enough, plus 270x. I say it's easy, then almost get it wrong. And then we have 6 times 27, which is 162. So plus 162. There we go, we've got our straight line. We now, as I said, we need to make this equal 0. So everything on the right there, let's move that over to the left and see what we get. So let's minus the 108x from both sides to start with. So let's minus this. So take that away from the 110x squared, leaves us with 2x squared. Then we've got the next one. So let's have a look at that number there. We've got 270x and we need to remove that. And we've got 220x on the left. So 220, take away 270, leaves us with minus 50x. And then the number at the end, 162, 330, take away 162 from both sides will leave us with 168. So plus 168, and that now equals 0, and that's where you pick up your 4th mark on this question. Right, so next thing, let's have a look. We want to factorise this, so let's see if we can make it a little bit simpler, which we can because all of our numbers here are even, so we can definitely divide them all by 2. And as it's 0 on the right there, you're allowed to do that because 0 divided by 2 on the right is still 0. So that now leaves us with x squared minus 25x plus half of 168, which is 84. And that now equals 0. And that's potentially going to make it easier for us to factorise. Now let's see if we can factorise this. So 84 at the end. And again, when you are factorising, always just write down your factor pairs. So for 84, we can have 1 and 84. We could have 2 and 42. We can have, does it divide by 3? 84, I believe, does divide by 3. Those digits add up to 12. So 84 divided by 3 is 28. So we could have 3 and 28. Definitely divides by 4. It'd be 4 and 21. And actually at that point there, we can spot that that is going to allow us to make this 25 in the middle. So it's definitely going to factorise. Didn't take too long to get there. So if we put that into a double bracket, which we can do up here, we would have x, let's have a think, minus 21. They're both negative, so x minus 21 and x minus 4 equals 0. That gives us 2 solutions. So we've got x is going to be positive 21 or x equals 4. Now if we refer back to some of the language in the question, it said that there were more than 12 counters in the bag. So chances are it's going to be this x equals 21. Obviously we are going to be looking at the bigger one. If it's stated it's going to be more than 12, and let's just refer back to our original expressions here. If blue was x plus 3, or if if we look at the 2x plus 3, 2 times 4 would be 8 plus 3 is 11. So that's why this question has stated that there's going to be more than 12, because obviously using x equals 4 would only give us 11 counters. But the actual question asked us to work out the amount of green counters, and as you can see, green was our letter x there. We've got that x equals 21, so in terms of the amount of green counters, green equals 21. There we go, and there's our final answer. If we wanted the amount of blue, don't forget it said that there were 3 more blue counters than green, so that there would be 24 blue counters. So there we go, there's our final answer. Lots of working out, a very big question there, a 6 marker, definitely up there with your real top end questions. So there we go, there's our question 3, I believe. Let's have a look at our next one. Okay, so moving on to our 4th question, we've got here that there are Y black socks and 5 white socks in a drawer. Josh takes at random 2 socks from the drawer. The probability that Josh takes 1 white sock and 1 black sock is 6 over 11. Show that 3y squared minus 28y plus 60 equals 0, and then also find the probability that Josh takes 2 black socks. So we've been given the probability here for one specific root, and that is whereby he takes 1 white and 1 black in no particular order. So if we look at creating our tree for this, or our expressions to start with, it's going to be very similar to our last question. So if you're okay with the last one, this one is very, very similar. So let's have a look. If we create our ratio this time, we have black and we have white. And we've been given that there are Y black socks, so Y for black, and there are also 5 there for white. And again, just like we've done before, we'll get the total there, and the total for those two is Y plus 5. And there we go. So if we go about creating our tree this time, we're just going to use obviously these expressions that we have here. So let's have a look. We've got black and we've got white, so if we have black going up and white going down. So black here is going to be Y out of the Y plus 5, and white is going to be 5 over the Y plus 5. Now this time we don't need to worry about the black root going up, because we want to have those different colours, one of each. So we're going to go down the white root, and then if we went down the white, we're going to go up the black root. Okay. So if we take out one of the white counters, in fact let's go upwards to start with, looking at this root, let's take out a black counter and then a white counter. So the white numerator will have not changed, so it's still going to be 5, but it's no longer going to be over Y plus 5, it's going to be over Y plus 4. And there's our second root for that one. Now let's think about if we took out the white counter to start with and we then take out the black. Well, the black numerator from the start won't change, so that will be Y over Y plus 4. There we go. So there are our two fractions, and we're going to take exactly the same approach as we did last time. We're going to multiply these together. So again, just like before, let's create a little bit more space. Okay, so now we've got a bit more space, we just need to work out these two multiplications of these fractions. So for the top one here, taking out a black and then a white, we've got the numerators, so 5 times y is just 5y, and on the bottom there we've got a double bracket again, which I'm going to skip the working out. We get y squared plus 4y plus 5y, which is plus 9y, and then 4 times 5, which is 20. The same for the bottom root, we've got 5y over y squared plus 9y plus 20. So we get the same answer for both of those. Now we just need to add these two together, and if you remember from the question, it said that this probability, or these roots, were equal to 6 over 11. So if we add those two together, let's put a plus sign over here, we get 10y over that denominator, y squared plus 9y plus 20, and that is equal to 6 over 11. And again, we've got a similar question, we just need to cross multiply. So if we cross multiply these and see what we get, 11 times 10 on the left there gives us 110y, and that is going to equal, and we're going to times this other one by 6. So we will have 6y squared plus 6 times 9, which is 54y, plus 6 times 20, which is 120. There we go, and we have got our quadratic. Now again, we need to make it equal to 0. So rather than taking away the 6y squared, we're going to take away the 110y from both sides. So we've got 54y on the right, and we need to take away 110y from both sides. That leaves us with negative 56. So we'll have 0 equals 6y squared minus 56y plus 120. And again, we need to go about actually factorising this. So can we simplify it at all first? Yes, we can. We can divide both sides by 2 just to simplify it down. So we'll have 0 equals 3y squared minus 28y plus 60. Okay, so we still need to go about factorising this. So let's get rid of some of this working out here, and then let's have a go at actually factorising it. So we've got our factors over there, which are 60. Now let's write the brackets to start with. We know it's going to be a 3y and a y, and we'll have a look at the factors. So for 60, what could we have? We could have a 1 and 60, 2 and 30, bearing in mind one of these is going to be multiplied by 3. We can have 3 and 20. Is that going to work? No, that's going to make 29. Do either any of these work so far? Doesn't look like it. What else could we have then? We could have 4 and 15. Does that work? That could make 12 and 15. That would make 27. So no, that doesn't work. We could have 6 and 10. That would make 18 and 10. That would work. That makes 28. There we go. There is our factor pair. So 6 and 10. Obviously bearing in mind if you have a calculator for this, then you could just straight away use the quadratic formula, but I'm going to be doing this as a non-calculator method. So there we go, 6 and 10. We want the 6 to be tripled, so we'll put the 6 in the other bracket, the 10 over here. We're trying to make minus 28 in the middle and positive 60 at the end, so they are both going to be negative, and that's going to give us our two solutions there. We've got y is equal to 10 over 3, and y is equal to 6. Right, there we go. So we know that y cannot be a fraction because it is the amount of blue counters that we're looking at here. I think it was about counters. I've actually now forgotten about what the question was about because it was so long ago. So always make sure that you do write these questions down. So this particular question was about socks. So it was about black and white socks, not counters. So the answer for y that we're looking for, we've got y equals 6. So we can put that into our original ratio up here, y equals 6. And we have actually shown the first part of the question. I actually just went completely past part A, which was to show that 3y squared minus 28y plus 60 equals 0. And part B was to find the probability of taking 2 black socks from the drawer. So in order to work out the probability of 2 black socks, we now know that there are 6 black socks out of the total, which is 11. So it is going to be 6 over 11 for the probability of taking the 1 black sock, and then we need to find the probability of getting the 2 black socks. So we will have 6 over 11, and that will be multiplied by 5 over 10, which is equal to 30 over 110, and that can actually simplify further. Let's just get rid of some of this. We can divide the top and bottom by 10, which would give us 3 over 11 as our final answer there. Okay, cool. So we proved our quadratic. We solved that in order to find how many, or what the value of y was, so we knew that how many black socks there were. And then once we knew that there were 6, we know that there's 11 in total, so it was 6 over 11 multiplied by 5 over 10 once 1 has been removed. That gives us 30 over 110, and that simplifies to 3 over 11, and that is the end of that question there. That was actually a 7 marker and an awful lot of working out, although I don't think the algebra was quite as complicated in that one as it was in the previous one, but there is an awful lot of working out in that question. So there we go, there was question 4, our final answers there. Let's have a look at our final question. Okay, and for our final question then, and you're going to see there's only one real difference or major difference in this question, and we're going to apply that in the first step, and this question is a calculator question, so that might give you a little hint as to what we're going to have to do at the end. Now it says here that there are some red counters and some white counters in a bag, and let's quickly make our ratio straight away. At the start, 7 of the counters are red and the rest are white. So 7 are red. We don't have a number here or a letter to use, so we can pick our own letter. Let's go with the letter X. So in order to get the amount of white counters, X is our total, let's say white would be X minus 7. Or we could actually put white as being X, and then we could have our total in a slightly different way. So there are different ways of doing this, because we could have our total now as being the X value, or we could rearrange this and give white as the X value, and then make our total there as X plus 7, which is probably a little bit easier to do. But when you're not given the letter for any particular part, there are 2 different ways that you can create your expressions. Both will work, but this is probably our easier way to do this. So for this one then, it says Alfie takes at random a counter from the bag, he does not put it back, and then he takes another one. The probability that the first counter is white and the second counter is red is 21 over 80. Now the nice part about this question is that only gives us one route to work out. So the first counter is white, the second counter is red, and our probability there is 21 over 80. So actually this hopefully shouldn't be too much of a large tree, because we're only going to look at that one route. So if we draw it in, we have got 2 options. That's going to be red and white, and we're going to take the first counter being white. Now the first counter there is going to be X out of the total, which we've written down as X plus 7. Again, X over X plus 7 just taken from our ratio. If we were to write red in as well, which we don't need to, but it would be 7 over X plus 7 for red. Now the second counter that we are going to take is going to be red, so that's going to be the uproot, and we're not going to draw the whole tree for this one, because we're only going to look at this one part of the journey, which is taking out a white and then taking out this red. Now the probability, and this is why I wrote down the probability for red there, because we've taken out a white, the numerator is not going to change, so that is still going to be 7, although it is going to be out of X plus 6 now, as one of the counters has been removed and not replaced. So there's our 2 fractions, X over X plus 7. We need to multiply that by the 7 over X plus 6. And those 2 probabilities there are going to equal 21 over 80. Let's see if we can fit this all in. So X times 7 will give us 7X on the top. And then we are going to have a quadratic there, X plus 7 times X plus 6, which is going to give us X squared plus 6X and 7X, which is going to be 13X, plus 6 times 7, which is 42, and just about fit that in. Now if we get rid of the tree, we can set that equal to our fraction and go about forming our quadratic. So let's get rid of all of this, and again you can hopefully see a lot of similarity between this and some of our previous questions. So we have 7x over x squared plus 13x plus 42, and that probability is equal to 21 over the 80. Right, so again, just like before, we need to cross multiply here. So we're going to times the 7x by 80 and this quadratic here by 21. So let's write that out. So we have 80 times the 7x, and that is going to equal 21 multiplied by the x squared plus 13x plus 42. And now if we expand that, obviously we just need to multiply them out. So 80 times 7x is going to give us 560x. That's going to equal 21x squared plus, we've got 13 times 21, which is 273. As I said, you do have a calculator for this one as well. 273x plus 42 times the 21, which is 882. So plus 882, and you can see why you have a calculator for this one. And there we go. Now we need to make that equal 0, so we need to take away this 560x from both sides. So we'll get 0 equals 21x squared. Let's have a look. 273, take away that 560, leaves us with negative 287. So minus 287x plus the 882. There we go. Right, so we have a pretty nasty looking quadratic there, and I wouldn't know off the top of my head whether they all simplify. I suppose you could test them if you have a calculator. There are little tricks to see if things do definitely divide, but as we have a calculator, we don't actually need to, okay? We don't need to try and factorise this, even if it does factorise, which we know it has to factorise because there is, the value of x is an amount of counters. So we must be able to factorise it to get a whole number, but there is absolutely no point in us sitting and trying to factorise that, which could take us a little bit of time. We may as well just plug it straight into the quadratic formula. So hopefully we know our quadratic formula, minus b plus and minus the square root of b squared minus 4ac, and that is all over 2a. Now for this one, our values, we have a equals 21, we've got b is equal to negative 287, and we've got c is equal to 882. So all we need to do is plug these values into the quadratic formula and find our value of x. So let's get rid of all of this and let's just go about typing this in. So we've got minus the b, which is going to turn that negative 287 into 287, plus and minus the square root of b squared, now that's negative, so we'll put minus 287 in brackets squared. Obviously when you square it, it's going to become positive anyway, so we could just put the positive version in. Take away 4 times 21 times the 882 all over two lots of a, so 2 times 21. Now we're going to get the one where we do the positive and the one where we do the negative. Let's type them both in. So fraction 287 plus the square root of 287 squared, take away 4 times 21 times 882 all over 2 times 21, and we get the answer 9 for that one. Let's go back in and put the minus sign in and see what we get for that. There we go, and we get the answer 14 over, let's have a look, 14 over 3. There we go, 14 over 3. So we know that our answer has to be the 9. We can't have 14 over 3 counters here. We have to have a whole number. So we know that that value of x, and let's label that back at the top here, must be 9 white counters. Let's just read the question. It says work out the number of white counters in the bag at the start. So there's our answer, 9 white counters. Okay, so we can write that down here. The number of white counters equals 9. There we go. Right, okay, so again, another little topic being involved there using the quadratic formula. But as I said, that one there potentially, well, will have factorised, but would have taken you a lot longer. So if you do have a calculator and you are able to use the quadratic formula, then you may as well just use it on a question like that. But there we go, that was our final question. Hopefully that gave you a bit of an insight there into some really tricky questions to do with probability. As I said though, a lot of these I have done little videos on, so do check those out in the description if any of these were sort of, you know, quite tricky or something you feel that you need to work on. But there we go, hopefully you liked the video. If you did, please like, please comment, please subscribe, and I'll see you for the next one.